So we consider number 6. Number 6 says that the puck is moving to the right while the puck is moving to the east and then experiences a force to the south. So in this consideration, we have to think top down. So I'm going to address the motion map picture where the puck is starting in this upper right-hand corner. Over here you have a compass. There. So initially, we know that the puck is moving to the east. So as I'm moving to the east, and your work does tell you to use 3 different colors, so here I have the colors. The puck is moving to the east at a constant velocity. The velocity is constant, so there is no acceleration. That's acceleration. That's velocity. And if it has no acceleration, it has no cause for acceleration, so it has no net force. It does have a constant velocity, so the object will be here in the next instant. And at that instant, it will still have a velocity that is constant. It will not have an acceleration. And it will not have a net force. In the next instant, the puck will be here. So we can see that the puck's motion is constant because it is at regular occurring intervals. And these arrows do not change. They are intended to all be the same. And now it's going to experience a net force, or a force to the south. So in the next instant, the puck will be here, but it will also be having a force applied in this direction. So while we still have this going on, and we have this going, and we have this going, now we also have motion in the south direction. And this is called two-dimensional motion. And it can also be called forces in 2 dimensions. I have a constant acceleration. I know that because it tells me it experiences a constant force. It is not necessary that these 2 arrows be the same size, only that they are in the same direction, because force causes the acceleration. If I push an object in that direction, and that is the direction of the net force and the direction of the acceleration. So this is the part where it gets kind of iffy for students. In the next instant, the object will have moved that far and will result as being here. We call that the resulting motion of those 2 being combined. So at that point, I still have that. Still have no acceleration in the east direction. Therefore, I still have no net force in the east direction. I do, however, have an acceleration in the south direction. So my velocity arrow will become larger. My acceleration arrow stays the same. And my force arrow also stays the same and in the same direction. The object will travel this far in that direction, and this far in that direction, and will now be here. We still have not provided any acceleration in the east direction. We still do have acceleration in the south direction. So we will continue in this fashion until we run out of space, pretty much. And then if we wish to know where this object is going, we always just draw that. that's where the object is going to be. So we can see that this is called forces. It can also be motion in 2D. 2 dimensions opposed to what we've been working with a lot is just single dimension, either forwards, backwards, or up and down, left or right, and now we're combining. You can combine any 2 directions you want to come up with what we're looking at here. Where does this have to do with anything you've learned in the past? Because if you'll remember, that's what we're concerned with, how to apply things that we already know. Okay? So upon further consideration of this object, we see that that indeed, when I do this and draw this line there, then this becomes the shape of a triangle. So how can I find this? Well, if I know what this side is, let's say this side is 3, then this side must also be 3 because it is a rectangle. If this side is 4, then I know 2 sides of the triangle, so then I can find the side of the hypotenuse by applying Pythagorean's theorem. A squared plus b squared equals c squared. So this is the part of your algebra that will come in on this part. We can do what we call is resolve the resulting vector by applying our algebraic equation a squared plus b squared equals c squared if we know the length of 2 of the sides. Now I made these numbers up. They're purely imaginary from my head. They're simply to make the numbers easy to deal with because I know the sides of the triangle that have sides 3 and 4. I know that that hypotenuse is going to be. So I take A, and it doesn't matter which one's which. 4 squared plus 3 squared. 4 squared is 16. 3 squared is 9. 16 plus 9 is 25. Take the square root of both sides, and we see that the value of that is actually 5. So why did I choose 3 and 4? Is because that makes a nice 3, 4, 5 triangle. 5, 7, 10, I believe, is another one that is nice and neat. In a lot of physics problems, we'll use that. Just because, so we don't have to worry about doing the math. So we will work some like this. We're not going to do them now. Okay, this is just kind of a preview of what is coming and why are we doing this. Because now we are leaving one-dimensional motion. We're going to start traveling and talking in 2-dimension motion. So we are talking, this could be any direction we want. Just 2. It could have been west and south, north and west, or north and east. It could have been X and Y direction at the same time. It's just whatever 2 directions we're dealing with at that time. So on number 6, this is how you would draw the motion map. And when we flip the video off, I'll show you what to do with the force diagram.